is Marcos Guzman, and today I'll be presenting you with a reverse engineering presentation for the Piggylight. Let's get into this, shall we? Alright. And here are our customer needs. Since our target audience is teens and below, as well as adults, our device needs to fit customer needs and the primary use of the Piggylight, which include a brighter light bulb than a default light bulb, a superior and longer lasting battery than the default battery, a more quiet crank noise than the default crank noise, and the Piggylight overall needs to be used as a tool. All of these are based off of customer interviews, and the customer interviews range from adult, teen, and child. Design specifications. For the low brightness problem on the Piggylight, 3 new LED lights will replace the 2 default lights, thus making the Piggylight brighter. However, the new LED lights will have to be powered by a lithium battery that lasts longer and is 3.7 volts and 1000 mAh. To address the noise problem, in and out of the Piggylight, a 1 cm foam insulation will be added inside the Piggylight to dampen the noise of the hand crank. And also addressing the hand crank, it will be replaced by a circular crank that won't stick out and massively reduce the noise of the cranking of the Piggylight. Also, smoothing out the gears will also help with noise reducement. On the left, you can see a rough sketch of the circular crank. You can't see it that well, actually. Yeah, there you go. And on the bottom, you can see side, top, and front views of the proposed Piggylight. And on the top, you can see the circular hand crank, and on the front, you can see the 3 new LED lights, and on the side, you can see the 1 centimeter foam insulation. Here are the comparison of the 2 lights. On the right, we have the proposed light with 3 LED lights, and on the left, we have a real image of our default light with only 2 light bulbs. Here is our functional model. On our functional model, it really isn't different from our proposed model. Our proposed model, the only thing different with it is that it has a circular hand crank, and I guess the only difference in between those is that the default hand crank goes from, north to south, and the proposed hand crank is in more of a circular motion. But let's get to the functional model. When the person is applying pressure to the crank, the ratchet rotates the gear, and then the gear rotates the magnet and coil to generate electricity. The electricity goes through the wire, and it can be stored in a battery, and when it's in the battery, a light switch can be used to turn on and off the flashlight. Or the electricity goes straight to the light, and then when in a light bulb, the light can produce light energy. Influence of the design process. Some influences and improvements on the design process helped us understand how we can make the Piggylight more efficient in terms of making it more quiet by foam insulation, smoother gears, and circular hand crank. Equipping the Piggylight with 3 LED lights will make it more brighter and require a more powerful and longer lasting battery that will become efficient and can also be switched on and off. That made me say wow. Final proposed design. In addressing all the critical areas of improvements to the Piggylight, will have improvements in terms of brightness, noise, and efficiency to the Piggylight. 2 default light bulbs will be replaced with 3 LED lights that will be powered by a lithium battery with the specs of 3.7 volts and 1000 mAh. That will also replace the standard Piggylight. The Piggylight will not have its standard crank, and instead it will have a circular crank, and also to reduce the noise within the light, a 1 centimeter foam insulation will be added, and to help, the gears will be smooth. The new LEDs and the new battery will be better than the standard battery and the light bulbs of the Pidgeot, and the noise reducement is also effective in terms of insulation, circular crank, and smooth gears. And on this slide, you can see our final proposed design. On the top, you can see the circular crank, and on the side, you can see the 1 centimeter foam insulation with the hand crank on top. And on the bottom, which is the front, you can see the 3 LED lights. And then on the right bottom, you can see the rough sketch of the hand crank or circular crank. And that will conclude our presentation on the reverse engineering of the Pidgeot.